Hello, so today we are going to do this problem, part of today's contest, node with highest edges score. And the problem asks us to do, basically says that we have a graph with n nodes labeled from 0 to n minus 1, and each node has exactly one outgoing edge. And then the graph is represented with this edges array, where edges I means there is a directed edge from the node from the index I to edges I, to the value in position edges I. And an edge score is defined as the sum of the labels of all the nodes pointing to I, right? So all the incoming edges to I. And what we want is to return the highest edge score, the node that has the highest edge score. And then if we have multiple that have the same highest edge score, we want to return the one with the smallest index. Okay, so that's the idea. Let's take a look at an example. So these are the edges at list, which means 0, there is an edge from 0 to 1. So that's what we are representing with this. There is an edge from 1 to 0, which is this one. There is an edge from 1 to 0, and then there is an edge from 0, 1 to 2 to 0. So that's what's represented here, and you get the idea, the index to the value. So it's directed, so this is what we get. So if you take a look at these, both 0 has this edge coming into it, this one, and then this one, and then this one. So overall it has 4 edges coming into it. And what the score is actually the sum of the labels. So for 0, for example, 2 has an edge coming into 0, so we add 2. 1, same thing. 3, that gives us 3. 3, same thing. 6, 4, same thing, that gives us 10. If we'll take a look, for example, the other ones are smaller, so we don't need to take a look at them. But if you take a look at 7, there is this edge coming into it, this edge coming into it. The sum is 11, so it's bigger than the one for 0. So and if you do for all of them, you will find that the highest sum is, or the highest score is 11. That means we need to return 7. Okay, so that's the main idea. If you take a look at this example here with this, the two highest ones are 2, because you have 0 and 3 for 2, and then you have for 0 you have 1 and 2. So both of them have the score of 3, so they are the highest one equal. So we pick the smallest one, which means we need to pick 0. Okay, so that's pretty much the problem. Now let's see how we can solve it. Okay, so how can we solve it? So let's say we have these edges, and the indices basically are 0, 1, 2, 3, 4, 5, 6, 7. So one thing you will note is actually the problem describes it as a graph, but we actually don't need a graph even. We can just do exactly what the problem asks us to do, which is for each node calculate the score. And how do we do that? So the score here, we can just go through the edges, right? And go through the index is the source and the value is the destination, right? So what this would mean is that for 1, so we have source, this is I, and then destination, this is the value, right? So this would mean score of D would need to be, we need to add S, which is I, right? So the score of the value, we'll need to add the label of the node coming into it. So basically what this would mean here is that we have 0 coming into 1. Okay? 0 is the index, 1 is the value. So what we want to do here is the score of 1 needs to be incremented with 0. This case is 0, so it doesn't make a lot of sense. But if we take a look at this one, 4 coming into 0, this basically means that the score of 0 will need to be incremented with 4. Right? So this is the value, this is the index, which means the score of V needs to be incremented with I. Right? So basically each score is just the sum of the labels of the incoming edges. So that's why we do this. So basically a score of 1 starts out as plus 0. So we add 0. And then we have the score of 0, right, has 1, and then we have the score, so this is 2, the score of 0 has 2 again, so that means it becomes 3. The score of 3 to 0, so that means we need to add 3 as well, so this time is 6, and then now we add 4, so this time it becomes 10. And then we go to the next 5 to 7, so that means so is this 7 that we, yes, 7, so 5, so this means 7 has 5 now, right? This is the start to the destination. And then now 6 to 7, so that means we need to add 6, so that means we have 11 here, and then 7 to 5 means that 5 has 7. All right, and so we do the score like this. Basically, we are just traversing and then adding the score of the value plus the index, right? And now we go through the scores again and just find the highest score, right? And so we go through each index, and the highest value score we assign as the best node the key, which is the index. And so with this problem here, we go through them, we'll find that this is 11, the highest one, so we return 7. So that's pretty much the solution here. Let's just write it down more explicitly. Okay, now let's write down the logic that we have. So what do we need? So first we need the score hash map that we have in the overview over here. So we need collections, and we want to default it to 0 for the value, because the score initially for each one is 0, and for a non-existent, for a node that has no incoming edges, it's 0, right? So we want to default to 0, and that way we pass default dict int in Python. And then we just go through them. That's what we did in the overview. In enumerate of edges, and then the score, so this is the source, this is the destination, the score of the destination, right, increases by s. S is the index, and then this is the value. And now we need to choose the best value, so we can either go to scores like this with key and value in score. That's a valid solution, but even better, because we want, if we two things or two nodes have the same score, we want to get the smallest one. So to do that, we actually can just go through the nodes from 0 to n, because that's what the problem says the nodes we have. Now, what is n? Well, n is definitely bounded by the number of edges. You can't have more edges than n. You can't have more nodes than n, so we can just go through them like this. And we check if score of the best, so we need to have the best node so far, which let's call it just the best I. So if that score is smaller than the current one we are looking at, which is score of I, that means we found a better node, so we just assign it. And then at the end we need to return best that we found so far. Okay, and this will work because we go from the n from 0 to n, right? So that makes it work. Let's run this. Let's submit. Okay, so that passes. Now, in terms of time complexity, this is O of n, n is the number of edges, O of n here as well, so overall it's O of n time. Now in terms of space, we are doing one map here, so O of n space, which is at most of length n, so O of n space as well. Yeah, so that's pretty much it for this problem. The main idea is to not get too much caught up in the graph, and start constructing like a whole complicated graph, and just go with the simplest solution of just calculating the scores and getting the maxed one. Yeah, so that's pretty much it. Thanks for watching. Please like and subscribe, and see you on the next one. Bye.